initialize Genesis sequence.
Well, good afternoon, everyone. Welcome to the Thursday here at DevOps 2024. I can see many of you made the right choice to come to the Ask the Experts panel session. So thank you for attending. This session is all designed to be unstructured because it's about your questions. It's all about your questions because it's very rare that we have this many experts in one room that are working on Java. I'm kind of lucky that every day when I check into work or I'm on Slack, I get to interact and talk and converse with my colleagues, but this is your chance to connect with all of them. So I'm just going to do a bit of a brief introduction. We have from, wait a minute, is it your left? Your right, Victor Klang, Alan Bateman, Angelos Bibudis. I'm trying to understand who this for. So has anyone ever seen Dr. Deprecator and Stuart Marks in the same room?
It's like Santa Claus.
I'm not. Who are you today?
I am both and neither.
And neither. Okay. Minborg, Gavin Bierman, and Brian Goetz. So the format of an Ask the Experts, Ask Me Anything panel session, if you're not familiar with this, is it's your chance to ask questions to our team, to our panel of experts. We'd like to make this as productive as possible, and oftentimes there's so much information on the what and the how. What makes this useful is the questions on the why. So seriously think about the why so we can give you compelling and honest and authentic feedback. But for all of you who saw the tweet earlier this week and yesterday, who sent in some questions, we'd like to get through some of those first to maybe to warm up the room. And if you do have a question, just raise your hand. I'll come, well, should I run up the stairs? I'll come carefully up the stairs to bring the microphone to you so you can then present your question. So without further ado, to get maximized time out of this, and so raise your hand if you're willing to take the question. If you choose not to answer the question, I might have to put a dunce cap. No, we're not going to do that today. All right. So the first question, security manager. So we have a question. So these questions are all about decisions we've made, the current state of Java, and some futures. So just think about that as you formulate your questions. First one's on security manager. The security manager is being removed from the JDK without any form of replacement. Should we expect to see more of this in the future, which is worrying for some users?
That sounds like a deprecation question.
Yeah, it sure does, doesn't it?
I'll answer this with my deprecation lab coat on. So first of all, I think the fundamental idea of the security manager was to run untrusted code. And so the security manager was a mechanism to run untrusted code in the JDK. And in fact, basically nobody does this. So now, there still remains this idea of how you run untrusted code, and in fact, people do this every day using other mechanisms, using such as OS security mechanisms and container mechanisms. So in fact, the replacement mechanisms for the security manager exist and are in use and are in widespread use in the industry today, but those mechanisms exist outside the JVM. So it's not like there's no replacement whatsoever. It's just that we believe that the replacement technologies for the security manager are not in the JDK anymore. Now, there are a bunch of other deprecations in flight, such as finalization, such as unsafe. We will be providing mechanisms inside the JDK for those. And also, well, we haven't deprecated serialization yet, but we are working on a replacement, and you heard some ideas for how we would upgrade serialization. So for the most part, we do think about what people are doing with these mechanisms and what replacements they use. They just don't always exist in the JDK.
Would you call the security manager a peak of complexity solution?
Oh, yes, I think so.
Can I just add a couple of things there? Because when someone asks a question like that, they're actually not telling you a whole bunch of other things. What I would say is the story is written out carefully in JEP 486. There's a whole bunch of stuff in there that I don't know whether the person asked the question has read it or not, but there's things like, it references all the other things that are going on and that are much more interesting to invest in rather than the security manager.
Yeah, but you bring up a good point, Alan, which is a lot of times we have questions that actually the answers already exist. And so I'd encourage you, if you're not already active in the OpenJDK project, please find the projects that interest you, follow along on the conversations, because oftentimes what you're looking for has already been stated and discussed in terms of why a decision was made, why a decision wasn't made, and then allows you to then plan for that future. So definitely turn your attention to openjdk.org and join the mailing list and be part of the conversation. Fair?
Yeah.
Okay. So Dr. Deprecator, you sighed there towards the end. Was that purposeful?
Oh, about
Peak
I
of
think
complexity.
In response to Brian's question about peak of complexity, yeah, I think it fits. I think that's where it fits in the model.
Okay, good. All right. So this is actually relevant because we had a great keynote on the tip and tail. Brian and both George, where's George Saab? George Saab, there you go, leads the Java team at Oracle. Talked a little bit about tip and tail. And so the question is, JEP 14 tip and tail is for library maintainers. Can you explain why it's a JDK enhancement proposal or a JEP?
Yeah, so without going too much into the details of the tip and tail model, because that could take a good chunk of time here, JEPs are not just for features that we're adding to the JDK. There are several categories of JEPs. There's a category called process JEPs, which talk about how we do what we do in the JDK. And there's a category called informational JEPs, where we write down things that we think are relevant to both how the JDK has evolved, but also interactions in the Java ecosystem. So, for example, the preview process is documented in an informational JEP. And the tip and tail JEP is also an informational JEP. It has no weight of law, there's no specification, there's no thou shalt do it this way, but it represents the gathering of understanding that that we've developed through developing the JDK, and how we think it might benefit some libraries who may choose to adopt this model, and what the advantages and cost might be.
That's a fair question, which that leads into a whole set of other questions, because so many of our JEPs are talking about programs, projects, and features that we're working on, and many of you have had questions on preview features, which is great. Hopefully all of you are giving us feedback on that. Related to that is, I didn't see another preview feature of string templates in JDK 23. Why was it removed? Who's brave enough to take that one on?
All right,
Oh.
I'll take it. Yes, it didn't appear because we removed it. And
Oh, thank
So
you.
the obvious.
there we go.
Okay.
Indeed.
You removed it. Yes.
Great answer.
There we go. And it was deliberate. So it was a preview feature, and as we say to everybody, the best thing you can do with preview features is try them out with your code and give us feedback. And you won't be surprised to hear that we're also doing the same thing. We're also trying it out with new examples and gathering our own feedback. And one of the things we discovered when we tried a particularly complicated example, challenging example, we found some shortcomings in the design, particularly around, for those of you who played with string templates, is kind of a design with two parts. So one is something that looks like a string literal with holes in, with expressions in those holes. And then we had like a processor, which was a code that would process that template and the values and create a value to come out. And we discovered that our design, not of the string literal bit with holes, but the design and the API around the processors made it really hard for us to actually write the example that we wanted to write. In fact, in some places, we couldn't write the thing we wanted to write. So that made us realize that perhaps the design around the template processors was not quite right. And at that point, I'm going to read the manual. So we read JEP 12, which tells you what to do with preview features. And it says, and I quote, "Eventually the JEP owner must decide the preview feature's fate. If the decision is to remove the preview feature, then the owner must file an issue in JBS to remove it. No new JEP is needed." So we filed a bug to say we're deleting all that code and it disappeared. We did write and inform people. Obviously, we're discussing with the experts and so on. But that was the decision. However, it's not the end. We wanted, basically, we're in a position where we were sure that the design we had was not quite right. We're pretty sure we know what we want to get the design to, but at that point, it seemed like the best thing to do was to remove the preview, have a good long think, talk with the experts, and then come out with a new JEP with a new design when we're ready. The great thing of the 6-monthly cycle is not too long for another train to hop onto with a new design. So behind the scenes, in Java Towers, we are working hard on the next design, and fingers crossed we'll have something to share soon.
Very good. And so, going on to preview features, another very good question is, some preview features are previewed 1 or 2 times. I have noticed that the status of the Vector API is now in 2+N preview features. What's the status on Vector API?
So I can take that. So turns out the sorts of things that the Vector API has to do under the hood inside the JVM are remarkably similar to the things that Valhalla has to do in terms of being able to flatten objects into other objects. And the code that is in there is kind of a pale imitation of what the Valhalla code would be. And it seemed like it would be a terrible shame to have 2 implementations of roughly the same thing that didn't look exactly like each other. And so we decided that the rational thing to do would be to wait until JEP 401, which is the first JEP of Valhalla, came into preview. And then at that point, we would rebase the Vector API code on the Valhalla code, and it would go into preview at that point as well. So, and that actually flowed into the decision about how finely should we slice the Valhalla JEPs so that not only do we have a smooth delivery of features that make sense, to the programmers, but also that we minimize the time that the Vector API is waiting for Valhalla. So, what we ended up with in JEP 401 is kind of a nice balance of, it's kind of the minimal first increment of Valhalla, and it also unblocks vectors.
So wait, there's more.
So yeah, there's more.
So I still have a lot of questions that you've all sent in, so thank you. But I also want to ask the room, if you have a question, raise your hand. I'll come running up to you, or carefully walking. I saw your hand first.
This is the advantage of sitting close to the front of the room.
The question is about deprecating parts, for example, like the date class, for example, or hash table class, for example, because the Java doc already stated there are better alternatives like hash map and things like that. What is about that? Maybe to deprecate these kind of things.
So who's going to answer that?
There's only one person to answer this. The guy in the white coat.
Yeah. Right. Okay. So there's a set of classes in libraries that are obsolescent in a sense, but which are not formally deprecated. And so one of the things that so the examples are the date class. What's interesting about the date class is that almost every method and constructor of date is deprecated except for a very, very carefully tuned set. But so date, vector, hashtable. I think I said that last year when I answered this question. So there's a set of obsolete classes in that state, but they're not deprecated. Why not? Okay, so we will probably never actually remove them because too much code depends on them, and that would just be incredibly disruptive. We could deprecate them not for removal, and what that would do is have the effect of generating a bunch of warnings. And one of the problems is that since these are very old classes, they work their way into library APIs. And so, for instance, the SQL libraries use date. And there's a There's some other issues with that, and then there's some early mistakes that made. But what that means is that all of these libraries and all users of these libraries would just start to suffer warnings. And if you have a warning, it might be, the idea of a deprecation warning is to say, oh, okay, there are better ways to do something than to use this API. You should migrate away from it. But if you're using a library that has this in its API, you can't migrate away from it until the library migrates away. So it's just this endless cascade of everybody transitioning away from these old things. And so maybe in a sense they should be deprecated. Maybe there should be a way to deal with warnings better. I think I'd like to do that, but that's still an open question. So sort of conceptually they're deprecated, but I think we need to do some more work to figure out how to deal with the situation.
Yeah, and I think a middle ground is to document the alternatives instead.
Yeah.
So that kind of nudge users to use other classes.
Mm-hmm.
Cool. Thank you. I have a question which probably goes to Alan. So I would be curious about the I/O Uring work, and also in general, what's your thinking about doing specific implementations for things that are only available on some systems and not on other systems? Because it's a lot of work for one specific thing. And what's the weighing there as such?
All right, so I think there's a couple of parts to your question. So I/O Uring, I think I'm guessing you're asking in the context of virtual threads and file I/O. Okay, so there's a dozen pieces that are required in order to make that work. We have had several prototypes and iterations. None of them have provided benefits, for the simple reason is that the bookkeeping overhead of using the complexity of I/O Uring ends up being more costly than doing some of these operations synchronously. Because remember, particularly with things like SSDs, you're talking about I/O operations that are in single digits of microseconds. And so anything that would require using other threads or other kind of bookkeeping associated with that ends up being quite expensive. So there is in the JDK sandbox a Java API that is layered over I/O Uring. It's actually using the FFM API. It's actually a good demonstration of using that. There's a lot more work required to make that more efficient, but that was, for one of the explorations on this was the code base that was actually tried out. At one point, we did have actually all of the socket APIs actually working with I/O Uring. The performance compared to our ePole-based pollers was in the noise, so there wasn't a benefit there. And then the third thing that we were wrestling with for a long time, and we've been wrestling with it for a number of years, is actually being able to distinguish between file connections to local files, where you're actually just using solid-state storage, versus file descriptors that are to files in some cloud storage or some remote file system, because the cost of those I operations are very, very different between the two. And how do you actually know with a file descriptor which one you're dealing with? So we wrestled with some of the probing around that, but didn't actually come up with some good answers on it. So for the moment, it's actually kind of currently canned in favor of some other higher priority work, but we do need to come back to it at some point, particularly for these applications that want to have a huge number of threads doing file I/O. I think the second part to your question, maybe Per wants to take it, which is around writing. I think your question was around OS-specific code, and I'm guessing this is using system calls on particular operating systems. This worked quite well with FFM. I'm sure Per would like to say more about that.
We have tools already like JExtracts, which allows you to extract an API from C and then use it from Java directly. So that's always an opportunity to try out native code in a very cheap way. So you can remain in all Java code and still call native code. So I think that's great to just get a feeling of what can this do in my project. So you always have that kind of escape hatch.
Yeah, so it was also a little bit about how do you weigh if you want to put in the effort to, for instance, support a specific feature, right? So this is all the other things that you can do as such, which could give a good or big benefit on this platform, but then you have to weigh it against all the other work that you can do. So that was just also a little bit curious about that aspect.
Right. So I think if I understand your question is you want to provide an API or some feature that runs across a wide range of platforms, but you can optimize it for a particular, for, I don't know, Linux, whatever it might be. And I think what you're asking, are you asking maybe for some advice around how to get that?
For the JVM itself.
Yeah, how do we make our decisions?
How you decide as architects, are we going this route, are we not going this route? How do you weigh the decisions?
There isn't an easy answer to that because it depends on the feature. And also, sometimes we have some kind of insight into whether this feature could be optimized in the future on other platforms. So sometimes we might be biased towards some particular platform, knowing that in time and with enough energy, we could actually make it faster on other platforms.
And one of the questions we ask ourselves about, is this feature worth investing or not? The sort of first filter is this something only we can do? Or is this something the ecosystem can do? And as Per pointed out, the range of things the ecosystem can do in terms of interoperating with native libraries has gotten much bigger, right? So the set of things that only we could do has accordingly gotten smaller, and that gives us more flexibility about how we allocate our resources. And there are some things like let's say XML parsing that we have in the JDK that are not things that only we can do, but that are there because we judge them to be, the sort of thing that we expect that everybody expects is in the JDK, right? And then there's multiple levels of like guessing about relevance, involved there. But we do try to focus our effort on doing the things that only we can do because that's where the most leverage is.
Batteries included is the phrase I think you've used in the past.
Hi. If an exception occurs too often, the JVM can decide to omit the stack trace, which makes it difficult to compare exceptions to each other and say equals contract can't be ensured. Is this approach or idea to change the say behavior of an exception at runtime or the contract of the exception, what one can expect? Would you still stand by that? Do you think that's still a good approach, idea?
I was with you until you used the word good. Okay. I think there's no good answer here. And many of the decisions that we find ourselves staring at are ones where there's no good answer, right? So what the questioner is alluding to is, the JVM makes trade-off between specificity and performance, where there's some code out there that stupidly, we all agree it's stupid, stupidly uses exceptions as a control flow mechanism. And, well, that's pretty slow. But some of that code is buried in strategically important libraries in the Java ecosystem, and and so the JVM has a heuristic that says if this particular exception was thrown a certain number of times, we're going to throw and we can't tell that the stack trace has been consumed by any of the the enclosing catch handlers. We're going to throw a truncated exception that doesn't carry the stack trace. This is the sort of hold your nose and do a disgusting thing engineering that is basically the world we live in, because the world is so messy and the set of competing use cases and workloads is so diverse that we find ourselves making these decisions all the time. So is there a good answer to this question? Absolutely not. But both of the, but the obvious answer of just don't do that is also not necessarily realistic. And so sometimes we have to do ugly things. It's just how the world works.
Whatever happened to tail call elimination as part of Project Loom?
Alan, you want to take that, or you want me to take that?
It's in the tail. There's higher priority things, so it's a cool thing to work on. It just hasn't had. Doesn't have to make the priority list. If Ron is here, he'd be jumping up and down because it's something that he was really, really interested in actually working on. It's just a matter of priorities as to whether this is a good thing to work on or not.
And one of the things that feeds into that priority decision is, what is tail call elimination for, right? It is not a feature that people are going to use directly. It is something that that certain languages are going to use as a compilation target, right? So in order for tail call elimination to be useful, you have to have libraries that use idioms that benefit from tail call elimination. And it turns out that those library idioms don't work particularly well with the idioms that are, in the JDK written more broadly. And so adding tail call elimination, well, that's like, great for compiling functional languages to the JVM, which is not to say that we don't think that that's a valuable thing, but it's probably not our highest priority. But it also is a commitment to doing another 1 million hours of work to rewrite the collections and all the JDK libraries so that so that they're more amenable to those sorts of optimization techniques. And so if you're not going, if you're not going to do the rest of it, then doing the first part of it becomes lower priority.
So one thing I will say is that there, because it's something that has been on the table for a long time, is there are ideas for how this would actually be exposed in the language. There's ideas for what specifications would change to support this, but further work is just, as I said, lower priority.
Yeah.
So I think throughout this conference we've heard a lot about the projects that Oracle has run, and we've heard lots of examples of projects that have been quite successful and examples of projects that in hindsight could have been refined more before they were released. And I suppose, again, in hindsight, it's quite obvious the stages that the project went through and the state it was in when it was released, but it just wasn't something that was obvious at the time. So I was just wondering if you had any insight from a project management perspective on how to tell if a project is robust enough to be released and when a project should finally be regarded as done, given that projects run for, say, on a year scale.
So,
too good of a question.
Yeah,
How many
this is a difficult
project
question.
managers are here?
So, part of it is experience, right? Like part of knowing that you're about to make a mistake is because your experiences tell you either this looks like a lot like something that was a mistake that I saw or did 20 years ago, and sometimes it's just that your gut is telling you something of, we're not there yet. And that's a very difficult thing to quantify, and it's something that only comes from experience. And so, it's a little bit harder than the question of how do you tell when someone is lying to you, because it's really the question of how do you tell when you're lying to yourself. And that's a harder question, but fundamentally that's the question you're asking, is how do you know when you fooled yourself into thinking something is ready when it's not? And I don't have a formula, but it involves experience and trusting your gut. And when someone on our team says we're not there yet, we have a great deal of trust that they may not be able to explain why we're not there yet, but we recognize that discomfort and we know it's coming from somewhere, and we know it's worth digging into. So, but it also requires that you have the ability to stop and look at your solution and ask yourself, is this the right solution to deliver now? And not every team has that luxury. So I kind of recognize we're speaking from a position of privilege, but it's something that you grow to know when you see it, which is a totally unhelpful answer.
So what I would say as well is that using preview features actually means that there's actually time to think about something again. So if you're before preview features, we might have rushed to thinking and lied to ourselves that we think something is done. But the great thing about actually going through a process of having it in a release or two as preview means it gives you time to think, it gives you time to see whether there's feedback and realize, oh, this is actually not ready. So I think it avoids those mistakes.
I think also that we are a team. So when you have your own code that you're falling in love with, and then you go to your colleague and discuss it, and then say, wow, this looks great. Maybe you will finish up in half a year. and then you get this slap on your face when you thought that it was actually ready. So that's good.
Well, I think it's also about, there's a huge difference between ready and done. And I think software, in my experience, is never done. It's only ever obsoleted and not used anymore. So I think from a readiness perspective, it's about what it's supposed to be ready for. So is it ready for some initial feedback? Is it ready for some additional feedback? Is it ready for some prime time or not? So I think readiness is a spectrum as well.
And just to add to that, there's also a great amount of transparency in how we do development, which is it's not just the feedback we're getting internally from our own teams, but it's the comments that we're getting on our mail lists from the community itself. So we have to factor that into the decision-making process as well, which is why I keep advocating, if you want to help move Java forward, please participate. This helps us make those types of decisions.
Hello. I have a slightly specific question. So you were talking about this ecosystem versus platform, split. My question is, like, if we do like a lot of things in ecosystem and we optimize or use like new APIs, new technologies from the ecosystem perspective, what is the value proposition? I mean, like, I have a very specific question. Help me to answer the question for my leadership on why should we upgrade to new versions of Java if like we can put everything in the ecosystem and because usually where I find myself is I can play with the shiny things, new shiny things when they can have like something out, and usually that's a speed. Like you can say that Java is faster so that they can have like the cost cutting benefit, and then I can play with shiny things. Now that the speed is kind of set aside, what should be the value proposition? Sorry for the long question.
Yeah, I think it's not only about speed, but it's about reliability as well. We are fixing bugs all the time, and someone comes and says that you might have this slight security situation here, and we can fix it. So with every release, Java is getting even more secure. So I think that is an argument.
I think every release as well is getting faster too. So people upgrading from JDK 8 to 17 or 21 are just seeing significant performance improve just because of garbage collection or just because of other changes in the VM. So there's a lot of value there.
And I think there's an aspect of risk management as well, right? If you don't upgrade, at some point you'll run into a situation where you're forced to upgrade. And that will probably happen at an inconvenient time because you didn't plan for it. And so the longer that you go running an older version of anything, the greater risk you're at for something forcing you to upgrade on an hair-on-fire emergency, schedule. And like we've probably all had the experience of, you call a repair person to your house to fix something, and they give you that look of, if you had like replaced this thing 6 years ago, then like this would only be a $200 repair, but now it's a $2,000 repair, right? It's the same kind of thing. You can take more risk and let things slide, but you're taking a greater risk that you will find yourself in a difficult situation.
I think hiring comes into it as well for companies that actually want to hire new developers. If in the interview they'd hear, they're actually still on Java 8 and they're not going to be able to use these new language features and things, that's going to be disappointing. Whereas if they hear that the company is actually keeping up and developers get to learn the new features and work with all the newer JDKs, that's actually that might be more attractive too.
Yeah, and I think another aspect might be if you rarely or never upgrade, you don't know how to quantify what the cost is to upgrade. So by actually upgrading, you start to get a sense for what do we need, where do we need to look, and how long does it usually take. But if you never do it, it's hard to even make the argument what the cost-benefit ratio is. So I think that might be something to consider.
And if it hurts, do it more often.
Yeah, but I think also on the newer versions, the cost is much less. So if you go from 8 to something higher, it might be harder. But if you already are on 11 or 17, it's virtually problem-free, I would say.
So we finally have some questions in the back of the room, so I'm going to get my steps in by going up and down. So thank you to everyone.
By the way, Shrat, could you actually wave where you are? Because we
Yeah,
cannot see you
I'm
sometimes.
way up here.
Come on down.
Comes out the
There you
microphone.
are.
We have no idea
Okay.
where you are. Okay.
Can you see me now?
Yes.
Yeah.
All right.
Hi, I have a very specific question. We have a max function in the collections, and if I read that signature for that function in the Java docs, I see that it says public static t extends object and comparable. I wanted to ask why is the t extending the object and not only the comparable? Thanks.
So this is a little known corner of how erasure works.
Okay.
So there is very limited support for intersection types in Java. There's a few places syntactically where you can use an intersection type, and one of them is on the bound of a type variable. The definition of the erasure of a type variable is the erasure of its first bound. Usually there's only one bound, but sometimes there's more than one bound, and so it's going to use the erasure of the first bound. And so when you see generic that says t extends object and comparable, what the author was saying is, okay, I migrated this from a generic library where the argument of this thing was object. And I want to preserve the erasure so that generifying this is binary compatible, and therefore very infrequently, so infrequently that most of you have probably never seen this, which is cool, that's success, but it is there if you need it. You have this ability to say, I want this to erase to a more general type than the second bound.
That's your question? Okay. Raise your hand again. I'm sorry. Any more questions? Oh, let me work my way down now. All right. Am I going to make my steps for today?
More steps.
Yes. All right.
Thank you. I had a question about the history of languages. In the past, there was C and C++, and those only lasted about 5 or 6 years, and then you have Java, which has now gone on for 25 years. And so how do you see yourself in the history of languages? And so there are some competitors now, and we see our other companies going to other languages like Kotlin. What's your advice? And then is the future of Java, so it's a three-part question, is the future of Java itself, or you have something else cooking?
I'd say the C++ folks would be very disappointed. You think that they're over. There's quite a lot of C++ code.
C's been going on since 1972,
Yeah,
so
exactly.
it's had...
Right. Both C and C++ have issued new standards within the past couple of years, and they're continuing to work on them. So I would not agree with that characterization of those only lasting 5 years. And Python is older than Java and continues to go. So I think I'm forgotten. There are three parts of the question. I've forgotten them. But I think there's. Well, go ahead.
First one is. I keep looking for languages because I was so used to switching every 5 or 6 years. For doing business programming, Java's a good choice. Using C++ was crazy because it was for operating systems. So Java's going on strong. And so my question is, how do you see yourself in the history? It will keep going for another 10 years. And you do have other languages like Kotlin that we do see our competitors going to. And I'm wondering what's your future, if you have some other stuff cooking or it's Java itself.
So I'll take the last part first. We don't have anything else cooking. This is it. This is what we're working on. And we have a rich pipeline of things that we would like to do in Java. I think, underneath the question that you're really asking is, why do we have more than one programming language at all, right? And the reason is that there are different kinds of problems that we want to solve, and there are different languages that are better or worse for certain kinds of problems, right? So, Java has found a niche, more than a niche, in many different kinds of programming problems, but it's not the language you would use for everything, and that's why Java is not the only programming language out there. But it's a pretty good one, and it's applicable to a lot of things, and we want things to stay that way. But the reality is the environment we're in shifts out from under us, right? And so the way I look at this is from an evolutionary perspective, that programming languages evolve, and they evolve in response to their ecosystem, just like organisms do. So in the ecosystem of the 1950s, the programming problems that we wanted to solve were things like calculating artillery firing tables. And Fortran was an extremely fit predator in this environment. But even by the 60s, the problems that we wanted to solve looked more like the precursors of SQL queries. And COBOL was a very fit predator in this ecosystem. Things have changed. For the programming problems that we're solving now, Java is a pretty fit predator. But I think the question you're really asking is, what are the programming problems that we're going to be solving in 10, 20, 30 years? Well, we're not sure because we can't see the future, but we do try to watch the trends and constantly ask ourselves, is this something that Java is or could be a good candidate for? And if not, are we okay with that?
Yeah, I think also another way of looking at it is the sort of Java code you write today is quite different to the Java code that you wrote maybe 10 or 15 years ago. And that's deliberate, right? I mean, that's what some of us on this panel are trying to do, is to help you write different sorts of code. So, I mean, people often think that what we're doing is, in our day job is looking longingly at our competitors and frantically stealing anything that looks good. But the reality is that, whilst of course we do look at the competitors, but they and us, we're all language geeks. So we love writing code and looking at languages and so on. And all of the languages that people say are better than Java, they were not created in isolation. They all stole stuff from predecessors too, right? So everyone, in the recent past, there was a lot of effort to make languages more functional. But of course, there's a whole history of functional languages since the 70s. So we're talking a lot at this conference about pattern matching, which we think is a very exciting extension to Java. But that really was invented in the early 70s in functional languages. So there's a lot of history to absorb, and all languages are in this sort of big evolutionary swamp. But we're not going to be able to take every feature, right? We're not going to be able to make Java look like, Prolog or something, because it's so radically different. But that's not to say that there aren't some things that we could be inspired from in those languages. So we have this sort of careful balance of thinking of what are the problems people are trying to tackle now, because they're different from 1995 and 2000, 2005 and so on. So what are the new things that they're doing? What things could they get some help on? And what of other languages in this rich history of programming language research can we pull on and adapt, because we can never, ever, ever, frustratingly, although it does keep us in a job, we can never just take someone else's solution and apply it to Java, because we've got the whole of Java to deal with, right? All of the decisions of our predecessors on the language design mean that we can very rarely just grab an idea and chuck it in. It requires a lot of work to make it the Java way of doing a particular thing. So it's a complicated process.
And just to add on that, so if you're not familiar with the JVM Language Summit, it's a summit that the Java team at Oracle does every year, which attracts some of the most renowned world experts in a specific language in terms of architecture or design, where we come together and collaborate and present on shared experiences and opportunities. And you're welcome to look at all of our recordings from JVM Language Summit on our YouTube page, youtube.com/Java. Many of the topics you just heard right now, especially about innovation in other languages that are targeting the Java platform, are there. It's a great resource for knowledge, and it will probably answer some of your questions. So just a plug for our YouTube channel. Thank you.
So to follow up on that, just can you give us a little hint about what big things there are on the distant horizon? We won't be taking notes, don't worry. But just a clue.
Well, I mentioned obviously the string templates which we withdrew. That's coming back, so we've got more stuff around strings. We want to make string programming easier, because it is something everyone does, and there's more that we could do there. We've got other bigger features around pattern matching. So in particular, we'd like to spread the goodness of pattern matching to all the classes, so all the classes can join in the fun. That's going to require quite a lot of work. But we think it's very exciting because there's another whole world of programming style that will open up if you have that. The APIs will be able to be changed. So you'll have new and exciting ways of programming your APIs, which we think is very cool. And also there's a very nice synergy between those features and the sort of stuff that Valhalla needs. And so we think actually that these features will combine with some other features. I think Brian mentioned the phrase type classes. So if there are any Haskell programmers out there, we're very interested in that feature because we think that some variant of that might help us with programming in the future where we ship Valhalla. So there's a few PhD thesis plus there for you.
And if something like that goes in, that'll have a significant impact on the APIs in the future as well.
Yeah,
so
absolutely.
Even the shape of the APIs that we're using now will be, there'll be so much opportunities for new APIs there. And I think in the selection of talks that were selected this year, there was quite a few things that were talked about that are quite far out. You know, in Per's talk today, talked about stable values and record mappers. We had serialization yesterday. There's quite a few things that are they're not the next release, but they're a little bit further out. So I think that was hopefully useful to people to see some of those things.
Yeah. Concerning the sizes of arrays, collections, and these things, we have now integers as a size, and I have the feeling that you could handle larger data structures than that, and that would imply indexing arrays with longs, size of collections would be long, and hash code would be long, which is a terrible transition. But how do you think about this? Thank you.
I can mention a little bit about that. So we already have now the foreign function and memory API, which allows you to flatten out data, and you can use indices of longs. So that's a way to survive until we might see something else in the future that we can do already today.
So in the deep dive on Monday, Morris Naftal and I discussed this a little bit, just a little bit of material in there. But I think there's this interesting question about, from a collections point of view, is there actually need to store more than, say, 2 billion objects in the same collection? Now, maybe there is, but the question is, do the abstractions we have today, such as list, are they actually amenable to storing more than 2 billion elements? And so would you want to put 2 billion elements in a linked list and search it linearly? I don't think so. Would you want to put 2 billion entries in a map? Maybe. Okay, he says yes. All right, well, that's good. But I think what we need to do, though, is figure out what those applications are. I mean, there's some scaling things, but I think there is a phenomenon going on, which is that computers are getting bigger and faster and everything. So there's this long tail of stuff where, so for instance, the garbage collection heap sizes, people talk about hundreds of gigabytes or even terabytes. But the vast majority of JVMs running out there are about 16 gigabyte heaps or something like that, below the compressed OOPS limit. So I think that's true of collections as well. Most collections are small. And so if we want to deal with extremely large amounts of data, I think that's okay. So if you have valid use cases for extremely large amounts of data, great. Let's think about how to deal with them. It's not clear to me that it's not clear to me that extending the existing collections is the right way to go about doing that. So we need to think about other ways to deal with that data and drive design of future collections around those. Or, as like Per mentioned, you have memory segment, where if you want to deal with many gigabytes of raw data, you can map that into native memory and then use all kinds of constructs in Panama to deal with that.
You can roll your own map, for example, with the linear probing and things like that. It's not that difficult to actually do that. And also I spoke about memory segment mapping earlier today, which is that you can have a record and say that, I want to have a mapper that can take this kind of record and just read and write it from memory. And so it will generate under the hood code for you that very efficiently will do this. And that will kind of take the edge of the complexity of writing such methods by yourself.
Let me just add too. So there's a sort of nice, why don't you just aspect to the question, which is, well, why wouldn't we just, raise the size limit on arrays and, make the size method of collection return long? And there are some surprisingly thorny issues, underlying the obvious move here. One of them that's not obvious is that when you get up to the gigabyte scale level, you don't actually want to lay an array out linearly in memory. You don't want your address computation to simply be multiplied, shift the index by the size of the element because of interactions with page tables and large pages. So you need a different memory layout for arrays, which are something low level, pretty baked into the into the JVM. So there's a bunch of significant rework required there. But then when you pop up to the language level, now you're asking, is it possible to compatibly evolve the API of the size method from returning int to returning long? And this is a pretty thorny problem because you're going to have old code that's compiled that thinks the descriptor of this method is returns int, and it might be acceptable for, if you could even link that call site, and there's a lot of work required to even be able to link that call site, because you have to have two versions of the method, generated, because otherwise old code won't find it, or you have some other mechanism of automatically adapting at link time, which undermines one of the nice properties of Java's dynamic linkage, because it's very fast based on string descriptors. Even given that, then what about legacy clients that call a size method that returns long, happens to return a number bigger than 2 to the 32? Should it truncate? Should it throw? So it's like nasty questions all the way down. And so the obvious thing is very difficult and probably awful to use. So that kind of suggests that what Stuart was saying about rethinking the problem is in order.
I think we're at time, but before we conclude, first off,
one more minute.
One more minute?
Yeah.
You want to take one more question?
Sure.
We'll go over. Where was he? There he is.
So the last decade, you have seen the move of documentation, the design documentation, more to the code. Like Rust is supporting Markdown and more native documentation towards the code. We've seen a lot of nice features towards Java, but not a lot towards Java doc. Are there any ideas on how to move forward and making changes towards the Java doc?
You can put Markdown in Java doc now.
Right. I would say that JavaDoc has moved forward in the last 5 to 7 years than it did in all its previous history. So it has support for Markdown now in 23, but there's so many other great things have gone into JavaDoc with the search and the layout and the support for things like finding deprecated methods, preview APIs. There's so many features have gone into it over the last few years. It's quite impressive. I think so. I don't know the context for your question, but one thing I notice is that many libraries in the ecosystem are not taking advantage yet of any of the JavaDoc features that have been there since JDK 8. And if you compare JDK documentation, which tends to try to always use the latest kind of features of JavaDoc, versus some of the libraries out there, there's quite a gap in there. So people think that some of the JavaDoc looks pretty poor, and it's kind of horrible to go and write JavaDoc tags and HTML and so on. But it has so much improved in recent releases.
So that said, I think there are some continued improvements that are possible to JavaDoc. In particular, Don Robb, who's an old Smalltalk guy. Smalltalk has a notion of method categories, and that doesn't exist in Java. And it's very useful for a class that has lots of methods to be able to categorize them. And so maybe that should be in JavaDoc. Just an idea that's been kicking around. There are a bunch of other stuff too, and also upgrading graphic design of the JavaDoc output would be nice too. So there's certainly more work to do, and I think we should have some feedback about what you need from JavaDoc that it's not giving you. So I mean we're receptive to that because there's more work that we can do.
main thing to take away is there is Markdown support in there now. I don't know how many people have actually tried it. There isn't a session on it this DevOps, but maybe sometime there will be.
So Brian, how are we doing? Are we at end now?
Yeah, we're at end now.
We're at end now. So before we all leave, thank you to all of our panelists for making time. Two call to actions. One, please visit openjdk.org. That should be the easy part. But number two, please sign up for some mailing lists and give us your feedback, because this is the input all of these architects and experts take. So it's your participation that helps out. Looking forward for you to helping us move Java forward. So thank you.
All systems are nominal. Initialize Genesis sequence.